In this lesson, we're going to keep working with trig functions and radians and special triangles, and we're just going to put a lot of stuff together in this one, because in the last lesson we covered all kinds of material, some of which was review, some of which was new, but I think it'd be helpful to just do a bit more practice with it. So here's some of the kinds of things that you're going to be asked to do. We want to determine an exact value for sine 2 pi over 3, or 2/3 pi. Same thing. When it says exact value, you want to think special triangles. Always. So don't reach for your calculator when it says exact value, because your calculator will round things and give you decimal answers. We want to use special triangles, and we want to leave our answers as fractions involving square roots if necessary. So what do we know? Let's draw a picture. So on a Cartesian plane, okay, so what we know is that theta, the angle, is 2 pi over 3. And you may recall from last lesson that pi over 3, just to give you to think about it, there's a couple ways to think about it. One, let's go back to degrees, the way you already know things. We saw in the last unit, or the last lesson, that pi over 3 was equivalent to 60 degrees. So 2 pi over 3 would be 120 degrees. Another way we could think about this is 2/3 pi. Well, we know that pi is 180 degrees, which goes all the way around to here. So we want an angle that goes 2/3 of the way around to there. Both of those concepts get us to the same idea, and that is that an angle of 2 pi over 3 is going to be in here. Okay, so there's theta. It's an angle of 2 pi over 3. Always goes from the positive x-axis to wherever the terminal arm is. There's where the terminal arm is. Okay, what we also know is that we want to work with our related acute angle, which I'm going to call beta. And I'll always call it beta for this course. The related acute angle goes from the x-axis, whatever the closest version of the x-axis is, to the terminal arm. So it could be going the same direction as the primary angle theta, or it could be going the opposite direction, as is in this case. Doesn't matter which way I measure it, because I'm not going to worry about whether it's positive or negative. I'm just going to worry about the magnitude of it. So if theta is 2 pi over 3, then beta has to be pi, which is 180, minus 2 pi over 3. Right? Again, this whole thing is pi. But this part here is 2/3 of pi. That means that this part here must be 1/3 pi. They have to add up to pi, the two parts. So beta is equal to pi over 3. Okay, so we know that. Pi over 3, again, remember, is like a 60 degrees if we're dealing with degrees instead of radians. So that is a special triangle. So beta is pi over 3. And if I just drop a straight line down like I just did, that's a right angle, so we can use our primary trig ratios. So for our pi over 3 angle, our pi over 3 special triangle, it goes 1, 2, root 3. Those are the side lengths of our pi over 3 triangle. Oh, but I got it backwards. Not quite right, sorry. 1, 2, root 3 like that. It was turned around on me. That's my excuse. Anyway, 1, 2, root 3 like that. And of course, the root 3 would be the opposite side for the angle, the 2 would be the hypotenuse, and the 1 would be the adjacent. So, all right, now I want to know what the sine of 2 pi over 3 is. Well, we know that sine equals, this is just another thing we know that sine equals opposite over hypotenuse, or y over r if we're thinking in terms of the unit circle. So our opposite side we just identified as root 3, our hypotenuse is 2. The last thing we have to think about is it going to be positive or negative? Like, so is the fraction root 3 over 2 going to be positive or negative? And again, there's a couple ways we can approach that. One way we can approach it is thinking about the cast rule. So we're in quadrant 2. We're doing all our work in quadrant 2, which is where sine is always negative. Since we're dealing with sine, sorry, did I say negative? I meant to say sine is always positive. Second slip of the day. Anyway, sine is always positive, and therefore it's going to be positive root 3 over 2. Another way we could think about it is we're measuring the opposite side, which is measured on the positive y-axis. It's above the x-axis, so all y values are positive in quadrant 2, against the hypotenuse, and the hypotenuse is always positive. So we've got a positive root 3 over positive 2, which gives us a positive answer overall. So however you want to cut it, that is our solution. Okay, let's try that same thinking again for cos of 5 pi over 4. 5 pi over 4 is a little bit more than pi, right? So pi would be from here to here. That would be 4 pi over 4. We want to go another pi over 4 beyond that, which you may recall is the same as 45 degrees in our other measure. So we want to go put our terminal arm down here. So from here all the way around here, that's theta. That's our 5 pi over 4. Our related acute angle, beta, is from the x-axis to the terminal arm. So in this case, beta is going to equal 5 pi over 4 minus pi, because we've gone past pi in this case. So 5 pi over 4 is obviously bigger than pi, so beta equals simply 1 pi over 4, or just pi over 4. That's our related acute angle again. And so that's what this is. So I've drawn a lot of stuff on here. I guess I can still squeeze a bit more on here. I was just going to draw my special triangle. Let's do it in a different color maybe so it stands out though. Let's do it in blue, light blue. So if I drop a vertical line like this, then remember if that's an angle of pi over 4, it's the one that goes 1 root 2 as the hypotenuse. And since we're measuring on the negative x-axis, which is the left of the y-axis here, we know that all x values are negative. So this should be a negative 1, actually. That's a good way to think about it. Also, we're not going to end up using the opposite side, but the opposite side is below the x-axis, so that's negative as well. I might as well just put that in there. And again, the hypotenuse is always positive. We're trying to find the cosine of this angle. So cosine involves the adjacent side and the hypotenuse. So cos would be negative 1 over root 2. And again, if we were to think about it in terms of the cast rule, if I were to just not worry about signs and work out the signs at the end, that would work as well. Cast rule tells us that in quadrant 3, which is where we are, tangent's positive, but the other two are negative, so that means its cosine would be negative here. Now this is our answer, negative 1 over root 2, but as it says just below this, we don't leave root signs in the denominator. Therefore, we do what's called rationalizing the denominator, and we're going to multiply the top and bottom by the same number to get rid of that square root. So I'll take that negative 1 over root 2. And what's going to get rid of the square root on the bottom is if I multiply by the same thing. So if I multiply root 2 by root 2, the two square roots cancel out and I'm just left with 2. But if I multiply by just that on the bottom, I'm changing my answer. So if I put a root 2 on top, root 2 over root 2 is just equal to 1. And multiplying by 1 doesn't change my overall answer. So what I get in this case is negative 1 times root 2, which is negative root 2. And then root 2 times 2 is, times root 2 is 2. So this is my rationalized answer. To extend this a little farther, we want to find the radian measure for the point 6, negative 8, and then state the primary trig ratios. Okay, so we got lots of room to do this. I'm going to draw a nice sketch. So 6, negative 8 is going to be, let's say this is 6 on the x-axis and negative 8 on the y-axis. So the point is here. This is the point 6, negative 8. So if I want to find the radian measure for it, what it means is connect that point to the origin with a line, and we want to find, when it says find the radian measure, it means find an angle, right? So I'm going to find theta, and then I want to state the primary trig ratios as well. So that's a different question. So there's really two questions going on here. First, we're going to try to find out what theta is. So again, theta starts on the positive x-axis and it goes counterclockwise. Theta is a pretty big angle. I don't know what theta is in this case, though. All I know is that it's a pretty big angle. We know that if I were to keep going a bit farther, a full rotation is 2 pi, so it's something more than pi, but less than 2 pi. But I need to find out exactly what it is. So again, let's use what we know. Beta's in here between the positive x-axis and the terminal arm, but I don't know what beta is going to be yet. I do know this, though. If I connect this, make another right triangle out of this here at 6, I know some measurements. I know that this side length here is negative 8 because it goes, down same length as this negative 8 here. So that side length's negative 8. I also know that this side length here is positive 6. And I can find out what r is, my hypotenuse. So r is the hypotenuse. I can calculate that using the Pythagorean theorem. If I take 6 squared plus negative 8 squared, and then take the square root of it, that'll give me my hypotenuse. Remember, when we square things, they always turn out positive. So r turns out to be 10. And that's my hypotenuse. All right. Actually, let's start by doing the primary trig ratios, because we can do those pretty easily now. We've got some side lengths. So sine, let's label the sides. This is the adjacent. This is the opposite. This is the hypotenuse. And sine equals opposite over hypotenuse. So that's going to be negative 8 over 10, which is negative 4/5. Cosine is adjacent over hypotenuse, and so that's going to reduce to 3/5. And tangent equals opposite over adjacent, so that's negative 8 over 6, and that also reduces, in this case, to 4/3, negative 4/3. Let's check it with the cast rule. CA ST. So in quadrant 4, which is where we are, cosine is positive. Check, that's positive. Other two are negative. Yeah, they're both negative. Looks good. Now, how I'm going to find my angle theta in radians is I'm going to take one of those trig ratios. I'm going to take the cosine one just because it's positive. It doesn't matter which one, but I'll take the cosine in this case. But instead of calling it theta, I'm going to find beta. And then I'm going to, once I know beta, I'm going to relate that back to find out what theta is. So I'm going to say that cos beta equals 3/5. Therefore, beta is going to equal the inverse cos of 3/5, or just 0.6, which is what it is as a decimal. We need to have our calculators in radians, which I do. So 0.6 inverse cos is 0.93. Let's round that too. What does that mean? Well, remember that's radians. So it's not 0.93 pi. Pi is just 3.14. It's literally almost 1 radian. So it's a little less than 1 radian. Remember quite a few lessons ago now, we saw that 1 radian was roughly equal to 57 degrees. So beta, this angle going backwards through here, is a little bit less than 57 degrees. So maybe it's like 52 or 53 or something like that. That looks about right. Again, I'm just trying to, we should be talking in radians, but I just want to keep giving it terms of degrees so you can relate to it. So if that's what beta is, then we just have to look at the relationship between theta and beta. We know that a full rotation all the way around is 2 pi. We know that beta is 0.93. Not 0.93 pi, just 0.93. Theta is the difference between the two of them. Theta plus beta equals 2 pi. Therefore, theta equals 2 pi minus beta. So, theta equals 2 pi minus beta, in this case. So theta is going to equal 2 pi minus 0.93, and 2 pi is just roughly equal to 6.3, but let's put that in our calculator. 2 times pi minus 0.93 is 5.35. And again, that's 5.35 radians, not 5.35 pi, just 5.35 radians. So we can use either a point or an angle, and we can put everything together on the Cartesian plane and do those kinds of calculations.